What colors do I have? Bohr put the electrons in rings. This is the solar system model. So this is my, I want to coordinate. I had 3 protons, so there were still protons. So instead of the electrons just being wherever, and Rutherford didn't study them, he put them into rings. And the 8th graders are doing these ring structures this week, so you probably learned them in 8th grade too. The first ring can only hold 2 electrons, so I'll put 2 there. And then the second ring can hold more, but I'm only drawing 3 because that's what I have. So Bohr, like Beyonce, put a ring on it. That's how I remember it. You will too. So Bohr put electrons into energy levels. The problem with Bohr is that he only really studied hydrogen, and all of his experiments, they worked well with hydrogen, and then he tried to repeat them with other atoms, and they didn't quite work. He used like neon lights. He made gases glow, and then he studied the light that they gave off. His year, I think we have a gap in, oh no, his is not the gap. His was right before World War I. Then we have the gap. 1913. He used light in his experiments. The light that things produce when they glow, like when you heat up metal and it gets really hot and it glows red. That's what he was studying. Well, why is it glowing like that? And his model is called the solar system model. That's not really official. It's just kind of what they call it, solar system model, because it looks like planets orbiting. And we will actually draw Bohr models because the next one is really messy and it's hard to draw. Schrödinger and Chadwick, theirs is usually merged. In chemistry, we actually do separate them. Schrödinger is the one that came up with this electron cloud model. It's really the quantum mechanical model. But I got my protons in the nucleus. And Chadwick discovered that there was something else in the nucleus, adding in some extra mass. That something else were neutrons. They're neutral and they have no charge. Chadwick's name was James, like Jimmy. So that's where Jimmy Neutron got its name from, because James Chadwick discovered the neutron. They have no charge, so there's no charge on these. They weren't purposely put there, but in the nucleus, they help to keep all those protons from repelling each other because they don't like to be that close to each other. So Chadwick, he discovered the neutron in 1926. Neutron. And the neutron is neutral. It has no charge. I know all these ends go together, but there's also negative charge, and so we sometimes confuse them. Neutron, neutral, no charge. Oh, and it's in the nucleus. Then Schrödinger, he actually came up with this really fancy math equation with lots of Greek letters that looks really weird, but he said that the electrons, yes, they're in energy levels, but the energy levels aren't all nice and going in circles like this. The energy levels have all these different shapes. He did a big math equation and he plotted the probability of where you would find an electron. I'm just going to do a simple model because the actual little areas that he came up with are complex, and we study those a little bit more in chem and then AP chemistry. Okay, there we go. Oh, isn't that a beautiful piece of art? It's really like that. It's a probability model. There's a 90% probability that you'll find the electrons in this area. That's like too many electrons. There's only 3 of them, but at any split second, they could be in any of these places. it's like trying to watch a fan on high and just trying to zone in on one of the blades, and you're just trying to watch and it's all fuzzy and you're trying to find it. That's the electrons. They move so fast and so crazy. Whew. So Schrodinger came up with the cloud. He really had just a math equation. And this is just the probability of finding an electron. It's a big, weird Greek math equation. And then Chadwick over here, the neutron, that's in the nucleus. So I'll draw an arrow there. So we're going to combine those. The real name for that is the quantum mechanical model. Quantum mechanical. If you've ever heard of quantum mechanics, that's the beginning of it. And two more things that aren't really like the models themselves. Protons and neutrons are about the same size. These two things are about the same size as each other. So the size of a proton is approximately equal to the size of a neutron. And electrons are way smaller. If a proton or a neutron were about the size of an elephant, an electron would be like a cat sitting on that elephant. They're almost 2,000 times smaller. It's actually like 1874, but we're just going to round it. So electrons are much smaller, and that's why this is still a theory, because it's been hard to like take a picture of an electron. We've gotten down to the atomic level. I'm going to put 1,800 times smaller. Not just rounded. You need to know where each of them is located, that the protons and neutrons are in the nucleus. The electrons are outside of the nucleus, or in the cloud. Electrons are much smaller, but a proton and a neutron are about the same size. This is still our current model, but just so you know, the shapes, like overall atoms are spherical, but their different little energy levels have different shapes. But these dots just represent where you might find an electron. It's hard to track them. Right.